This is a medium difficulty problem. Here we have a weight of 5 kg that is tied to a string, which is wound to the pulley. We are asked what is the acceleration of the weight as the string unwinds without slipping. You may pause the video and read the problem fully. Let me proceed. Let us draw the forces in red. There is a force of gravity. There is a force of resistance, more like friction, that slows down the fall. The same force, but in opposite direction, will act on the pulley. This is force due to Newton's third law, equal and opposite. Now let us solve the problem. The net force on the weight is unbalanced, so it will give rise to acceleration. This is due to Newton's second law. The force on the pulley will generate a torque given by R cross product of F, or R times F times sine of angle between the vectors, which will also give rise to angular acceleration. The rotation of pulley is closely tied to falling of weight. It is given by this relation of angular acceleration with linear acceleration. We will prove this in a moment. For now, let's assume it. Moment of inertia is known as half times mass of pulley times radius of pulley squared. The equation in 2 with little bit of algebra reduces to this, which is force F in relation to linear acceleration. This force, when substituted in equation 1 and with little bit of algebra, reduces to this and gives the final answer. As promised, we now prove the relationship between angular acceleration and acceleration of the mass. In the figure, we see small change of angle related to arc, which is divided by radius. This is from simple geometry. But as we can see, the arc is also the height moved by the string, which is shown as delta D. Once you agree with this, rest becomes very simple. Now divide by delta t from both the sides and we get angular velocity equals to velocity of weight divided by r, which is also a very important relationship. Note that this relationship is because the string is unwounded without slipping. The rotation and translation motion is connected. Now take another derivative and we get angular acceleration and the acceleration of the weight. This is the relation we wanted. We finally get the answer for acceleration. In case angular acceleration is asked, it is simply acceleration divided by radius. We substitute the values of mass and gravitational acceleration and get the values of acceleration. Note that it is less than gravitational acceleration. It can never be more than acceleration of gravity. This serves as a rough validation that our answer is correct. Also interesting is to note that acceleration is not dependent on radius of the pulley. We also provide the values of angular acceleration in case it is asked in the problem. I hope you liked the video. Bye bye.